Imagine everything you know, every star, every galaxy, every planet, just one bubble in a vast cosmic ocean. Now, a Nobel Prize-winning scientist, at the top of their field, has made a claim that could change everything. After analyzing new data from our most powerful space telescope, they suggest we may be on the verge of discovering that our universe is not alone. This isn't science fiction. It's a hypothesis grounded in baffling new evidence. The James Webb Space Telescope may have found signs of something beyond our cosmic horizon. For centuries, we thought the Big Bang was the beginning of everything. But what if it was just the beginning of our everything? The idea that another universe, with its own laws and perhaps its own life, could exist parallel to ours pushes the boundaries of human comprehension. Scientists are electrified, some excited, some skeptical. Extraordinary claims demand extraordinary evidence. Colleagues are poring over the data, searching for alternative explanations for the strange anomalies Webb has uncovered. This is more than a scientific debate. It touches on our place in the cosmos and redefines what everything means. The Nobel laureate's assertion is a wake-up call. The universe is more mysterious than we ever dreamed. The story of existence is still being written, and we've just turned to a new, mind-boggling chapter. And it all starts with the incredible machine that made this discovery possible, a golden eye staring into the dawn of time. Meet the James Webb Space Telescope, or JWST, the most powerful space observatory ever built. Launched in 2021, it sits 1 million miles from Earth, its massive gold-coated mirror collecting light that's traveled billions of years. Webb specializes in infrared, letting it see through cosmic dust and peer farther back in time than any telescope before. It's like reading the universe's opening chapter for the first time. Webb is designed to answer fundamental questions. How did the first galaxies form? Where do stars and planets come from? Are there other worlds that could support life? To detect faint heat from distant stars, Webb must stay incredibly cold, protected by a sunshield the size of a tennis court. This delicate, complex technology lets us capture whispers from the dawn of time. And now, those whispers are telling us a story, stranger and more profound than we ever expected. Webb isn't just a telescope. It's our time machine, revealing the universe's deepest secrets. And it's about to rewrite everything we thought we knew. Before Webb, our story of the universe was neat and tidy. The Big Bang, a hot, dense beginning, followed by a slow, gradual formation of stars and galaxies. The standard model of cosmology predicted that the first galaxies would be small, clumpy, and disorganized. Cosmic villages slowly merging into grand spirals like the Milky Way. We expected the early universe to look fundamentally different from today. Evidence from the cosmic microwave background in Hubble supported this view. Scientists were confident Webb would simply fill in the details. We thought we'd confirm our theories, not challenge them. But the universe had a plot twist in store. Webb's first images didn't just add detail. They threatened to tear up the first chapter and force us to start over. The early universe, it turns out, was far more dynamic than we imagined. Our cosmic origin story was about to be rewritten, and the surprises were just beginning. Webb's first images stunned astronomers. Instead of small, messy galaxies, it found massive, mature ones, fully formed just a few 100 million years after the Big Bang. These galaxies had complex structures and were churning out stars at rates our theories couldn't explain. It was like expecting a baby and meeting a grown adult. Some galaxies, nicknamed universe breakers, appeared as massive as the Milky Way, far earlier than thought possible. Supermassive black holes were also found, much larger than they should be for that era. The early universe was assembling galaxies and black holes at breakneck speed, defying our models. The data was clear, but it didn't fit our story. The universe's early history was far more efficient and mysterious than we ever imagined. Webb's discoveries sent shockwaves through cosmology. The data was solid, no denying what the telescope saw. Scientists scrambled to check for errors, but the findings held up. If galaxies formed this quickly, maybe dark matter isn't what we thought, or perhaps a new force was at play. For some, it's thrilling, a chance to rewrite the rules. For others, it's unsettling, like finding a new continent on a familiar map. Science thrives on such moments. Old ideas fall, new ones rise. Some experts now wonder, Did our universe get a head start from something bigger? The multiverse hypothesis, once fringe, is now being considered as a serious explanation. Webb's data has forced us to think outside the universe itself. The multiverse sounds like science fiction, but it's a real idea in physics. The theory of eternal inflation suggests our Big Bang wasn't unique. New universes are constantly being born, each a bubble in a cosmic foam. Each bubble could have different physical laws, some hospitable, most not. The Nobel winner's hypothesis may be our universe inherited properties from a parent cosmos, explaining the rapid formation of early galaxies. It's like starting with a sourdough starter instead of just flour and water. Things move faster. We have no direct evidence of other universes, but if ours collided with another, it might have left a faint imprint, a cosmic bruise. Some think Webb's discoveries could be indirect evidence of such an event. It's speculative, but the strange data has scientists considering even the wildest possibilities. The multiverse is no longer just a thought experiment, it's a potential answer to the mysteries Webb has uncovered. The boundaries of science and imagination are blurring, and the search for evidence continues. If the multiverse is real, the possibilities are endless. Other universes could have more or fewer dimensions, different strengths of gravity, or even entirely new particles. Some might be empty and lifeless, others chaotic and short-lived. Imagine a universe where gravity is so strong that stars burn out instantly, or so weak that nothing ever forms. The speed of light could be different, changing the very fabric of reality. Chemistry might be unrecognizable, with elements and matter unlike anything we know. Our universe seems finely tuned for complexity, a cosmic Goldilocks zone. The multiverse hypothesis suggests we're just one outcome among infinite possibilities. Webb's data has opened the door to contemplating these stranger realities. Even if we never visit them, the idea expands our sense of wonder and deepens the mystery of our own existence. Webb's discoveries have launched a new era of cosmic exploration. Astronomers will gather more data, searching for more universe breakers and analyzing their light for clues. Theorists are racing to build new models that explain rapid galaxy formation and maybe even the multiverse. New telescopes are already being planned, each pushing the boundaries of what we can see. These discoveries matter to all of us. They challenge our understanding of where we come from and what's possible. The idea that our universe might be one of many is a philosophical earthquake. The journey of discovery is just beginning. Webb has given us a glimpse into the unknown and reminded us that the greatest truths are still out there, waiting to be found. The universe is bigger, stranger, and more mysterious than we ever imagined, and our story is far from over.